Here is a comparison of conventional well structure and hydraulic fracturing. Drilling conventional wells and those to be used in hydraulic fracturing begin in much the same way. The basic well construction steps are: 1. An initial length of steel pipe, called conductor casing, is inserted into a vertical well bore soon after drilling begins. This is done to stabilize the well as it passes through the shallow sediments and soils near the surface. 2. Once conductor casing is set, operators continue drilling and insert a second casing, called surface casing, from the ground surface and extending past the depth of all drinking water aquifers. 3. After allowing the cement behind the casings to set, operators continue drilling for 10 to 50 feet before stopping to test the integrity of the cement process by pressurizing the well. 4. In horizontal wells, after drilling the horizontal section of the well, operators run a string of production casing into the well and cement it in place. 5. Operators then perforate the production casing using small explosive charges at intervals along the horizontal well bore, where they intend to hydraulically fracture the shale. 6. Acid stage, consisting of several thousand gallons of water mixed with a diluted acid such as hydrochloric or muriatic acid. This serves to clear cement debris in the wellbore and provide an open conduit for other frac fluids by dissolving carbonate minerals and opening fractures near the wellbore. 7. Pad stage, consisting of approximately 100,000 gallons of slick water without proppant material. The slickwater pad stage fills the wellbore with the slickwater solution, opens the formation, and helps to facilitate the flow and placement of proppant material. 8. Prop sequence stage, which may consist of several substages of water combined with proppant material, consisting of a fine mesh sand or ceramic material intended to keep open or prop the fractures created and/or enhanced during the fracturing operation after the pressure is reduced. This stage may collectively use several 100,000 gallons of water. Proppant material may vary from a finer particle size to a coarser particle size throughout this sequence. 9. Flushing stage, consisting of a volume of fresh water sufficient to flush the excess proppant from the wellbore. Other additives commonly used in the fracturing solution employed include a dilute acid solution, as described in the first stage, used during the initial fracturing sequence. This cleans out cement and debris around the perforations to facilitate the subsequent slick water solutions employed in fracturing the formation. A biocide or disinfectant used to prevent the growth of bacteria in the well that may interfere with the fracturing operation. Biocides typically consist of bromine-based solutions or glutaraldehyde. A scale inhibitor, such as ethylene glycol, is used to control the precipitation of certain carbonate and sulfate materials. Iron control stabilizing agents, such as citric acid or hydrochloric acid, are used to inhibit precipitation of iron compounds by keeping them in a soluble form. Friction-reducing agents, also described previously, such as potassium chloride or polyacrylamide-based compounds, used to reduce tubular friction and subsequently reduce the pressure needed to pump fluid into the wellbore. The additives may reduce tubular friction by 50% to 60%. These friction-reducing compounds represent the slickwater component of the fracking solution. Corrosion inhibitors, such as N-dimethylformamide, and oxygen scavengers, such as ammonium bisulfate, are used to prevent degradation of the steel well casing. Gelling agents, such as guar gum, may be used in small amounts to thicken the water-based solution to help transport the proppant material. Occasionally, a cross-linking agent will be used to enhance the characteristics and ability of the gelling agent to transport the proppant material. These compounds may contain boric acid or ethylene glycol. When cross-linking additives are added, a breaker solution is commonly added later in the frac stage to cause the enhanced gelling agent to break down into a simpler fluid so it can be readily removed from the wellbore without carrying back the sand proppant material.